Okay, so now we're going to be looking at the text formulas. Now, first thing here, we've got UUID, which is going to be a unique identifier. Now, what this does is it basically gives you a unique identifier every time you call it. And so you're never going to have a call of this where you're not going to get a unique number. So if you call it 1,000,000 times, you're going to get 1,000,000 unique numbers or IDs, right? So if we call this here, here's our unique identifier, and then we can call it again, and we'll get a completely separate unique identifier, okay? Now that's quite handy if we need to create a unique identifier for a database that we're an admin for, right? We're creating a record. For some reason, that database doesn't create a unique ID. Well, now we can use this UUID to create a unique ID for our database so that we can reference it later on. Now, most databases do that. I'd say 99% already have a unique identifier, but if they don't, then you can create one there. You could also use that in conjunction with the data storage module to sort of create your own sort of like pseudo database. Although if you leave the ID field blank, it will auto-generate an ID, which is probably actually the same as mapping it with this UUID because it looks the same, same layout. Anyway, so that's the variable here. I've never used that one, but might be useful. Then we've got the length variable, which tells us how long a word is. So if we put in a word here and we put the length of that, it's going to give us, well, that was 12 characters, right? So we had 5 characters for Mitch, 6 characters for the last name, plus in a space, gives us 12 characters. Right, and you could also use that length on an array to tell you how many items are in an array. Then we've got the lowercase capitalized. So if we had Mitch here and we ran this, it's going to change that to all lowercase letters for us. If we put the capital I's in, then it's going to change it to all capital letters, which we'll put a few letters in there. And that will change that to all, oh, sorry, that will give it a title case. Yeah, title case. It should be upper, I think, as well. Yeah, see, capitalized was the first letter. So if I change that, and then start case would be first letter of every word. I believe there's probably one for upper as well, which would be all uppercase. Let's run that. So that's the first letter gets changed to capitalize. Then if we had multiple words, if we ran capitalize on multiple words, it would only do the first letter of the first word. If we ran it on start case, then that would be the first letter of each word would be capitalized. And there should be an upper in here as well. There it is. Sorry, didn't see that before. So upper will then uppercase all the letters for us here. All right, so next we've got the ASCII. Now this is useful if you've got sort of weird characters that are not supported by the standard ASCII character set. You can put that into here and then you can get your output. Now we're just going to put this in and it's just going to return the same text to us because they're supported. But if we had other text in there, it would strip it out and just give us our supported characters. So that would be useful if you're mapping into an API and it specifically says we only support ASCII characters. Well, then you could use that formula. The replace formula is quite useful as well. So we've got our character here. We're going to replace the word called world, and we're going to replace that with the value of house. Right, so hello world is our input, and then we're replacing world with, we're finding the word world and replacing it with house. So you could use that quite a lot throughout the different automations that you're building. It does come in handy. Then we've got trim here, which is going to give us removing of white space at the start and the end. So it will just get rid of all that white space at the beginning and at the end of the string. That's useful for when you're creating usernames and passwords and things. You just want to trim the white space. And also for when you're sending to different APIs, you will often want to trim white space as well. Then we've got the substring, which we might have the name of something, encyclopedia, right? And we want to just get the first value and get the up to the fifth value, right? So first character to the fifth character should give us like encyc. So that's 1, 2, 3, 4, 5. But if we wanted to get like the middle values of like 2 to 7, well, we could do that as well. And this is what's called zero indexed. So 0 is the first value, right? So this would give us 2 is going to be 0, 1, 2, right? So 2 is a C in this example, cycler. So that's our substring, which is quite handy if you're creating a specific ID of something and you just would need to get the substring of certain fields to then concatenate that into a string. So for instance, you might do substring of subject, right? And you want to get like the first 5 values, and then you also want to get the substring of another value, which might be, I don't know, the URL or something like that, description, let's say. And for description, you just want to get the next 5 letters of description. So if we were to run this now, we'll get the first 5 of the subject and then the first 5 of the description, which will give me like a fairly unique ID sort of reference. Now that's quite handy if, for instance, if you had duplicated an Airtable base, when you do that to say restore a backup, it's really hard to map from one base to another because they all have different IDs, right? Each base has unique IDs. So to get around that, you can create a unique ID identifier based on the values within the field, within the rows that you're trying to map to, right, to and from. And so you could just put 4 or 5 fields concatenated into one ID for each row, and then you could reference that in both bases and then use that as your ID to match between the two. So there's use cases for this sort of substring, and obviously you wouldn't want to put in the full subject and description because that wouldn't take up a lot of space. So that's useful for that. Index of is going to give you the actual character position of a specific character. So if we put, there's my name, and we'll just say, well, tell me where the letter C is in that in that word or list of characters. So C is the 4th position, the 4th index. And again, that's 0 index there. So counting from 0. Then we've got toBinary. Now, this is used mostly for things like running data into APIs. You could convert a file into binary data. We'll just put some letters into here, and then that will convert that particular value into binary. You'll often see binary returned for when you fetch a file from a source or when you create a file somewhere, and you'll need to convert binary into data to then upload it somewhere. So quite often you'll be receiving binary, but you can also create binary using that function there. Then you got toString, which that's quite handy if you've got like a number and you need to make sure that it's a string, or you can convert a number to a string or an array to a string or an object to a string. And we've got encoding URL, which let's just say we've got our URL here, and we're just going to put in some data, and we're going to put in variable equals 1, 2, 3, and you'll notice in a minute when we encode this that these specific symbols are going to get changed. So I believe the and is a 20 if I remember correctly. 26. No, 3D, yeah. 26 for the end there. So the unique characters, the special characters, quite often we cannot send those to different platforms. So we need to encode them so that when we send them across, that platform can read it. Now that's especially true for when we're working with JSON, because certain characters, and even doing API calls and things, because certain characters like forward slashes, exclamation, double quotation marks, question marks, exclamation marks, and symbols, they've all got special uses in different platforms. And so quite often we'll need to encode those so that when we're sending a link across, well, then it's not going to break the logic with those characters. They don't break it, right? So we can encode it, and then we can also decode it if we've been sent something that has that sort of encoding. So we can encode it here, get our special characters converted, and then we can convert those special characters back to a humanized normal format. Okay, then we've got escaping HTML. That's basically just going to do the same thing, but for HTML, right? So it's going to encode the HTML. Here we're doing the same thing for Markdown, so we're encoding Markdown here. Then for stripping HTML, well, that's just going to take all the HTML out of the text, which is quite handy if you're using like an email module and it doesn't have a text a text output and just has a HTML output, well, you can just strip all the HTML out and just get the body of the text there. Then we've got the contains variable, which we can look at, and this will return a true or a false, a Boolean. So if this array of values returns, has 1, 2, or 3, or has this value of 3 in the array of 1, 2, 3, then it will return true. So let's have a look at that using the split module. All right, so we're going to split this 3, and we're going to split with a comma. Now the split module is quite useful for converting a comma-separated list into a simple array. So how this works is we've got our text string here, and we can use anything to separate the data. I normally have commas. You could, I don't know if you could use you couldn't use a semicolon because that's a reserved character, a special character, but you could use spaces or commas, etc. And then you just tell this formula what character you want to separate by, and then this will return an array of those values, right? So here's our array, here's our 3 values in the array. Now, once we've got that, we could then see if our array contains, and we'll see if it contains the number 3 as the value, and we'll put our array in here. So now if we run that, we should get true. If we've done everything correctly. There it is. So it's checking this array to see if it contains that particular value. Now that's useful if you're writing formulas, an if-else formula. Again, I wouldn't normally use that. I'll just use a filter on a router to achieve that. It's a lot simpler. Then we've got the split, which we looked at. MD5, again, that's for converting characters into a specific format for sending it somewhere. Shell, same thing, shell 256, 512. They all just convert into separate languages to read. And then base 64. Now, base 64 I will explain because this one is used quite a lot in APIs, and you'll look at that inside of the API advanced course that we've got. Quite often you'll have, when you're sending a basic OAuth 2, you'll have the username and then the password, like so. Obviously, this will be the actual values, not just username, password. And they're separated by a colon. And when you're sending that as a authorization basic header, you would have basic in here, and then you'd always have to base 64 for username, password, most of the time. Some systems you don't, but 9 times out of 10, you'll have to base 64 it. So you could do that here, or you could just base 64 it using a tool on the internet, but obviously that's not as safe as doing it here. and then that's your login, done. So the other ones here, we've got our keywords. Now spaces are quite useful if that's clearing out spaces in, say, a formula that you're writing. You can put in a specific space, because quite often when you'll save a formula, Make will compress it and it will get rid of unnecessary characters and spaces. So this just makes sure that there's a space there. Then you got the NBSP, the tab, you got empty string, new line, carriage return, etc. So we'll go through where these will be used at the same time that we look at those in a separate video.